So problem 3a asks us to convert the surface 4y squared plus z squared minus x minus 16y minus 4z plus 20 equaling 0 to the standard form. And then we have to classify and graph it. So first things first is that we have to rewrite the equation so that x is equal to 4y squared minus 16y plus z squared minus 4z plus 20. Afterwards that we factor out our variables, so then x is equal to 4y minus 2 squared. And the reason that is because the 4y, whenever you get rid of the 4, this 16y immediately becomes a 4y, but then once we square it, we get y minus 2 squared. Likewise, we do the same for the z, but since there's no variable in front of the z, we keep it as is, minus 2 squared. Now, we don't have to add the 20 because the 20 is the result of these two areas. So once you completely rewrite the entire polynomial of y minus 2 squared and z minus 2 squared, their last coefficient will get you the plus 20. As a result, our final answer is x equals 4 times y minus 2 squared plus z minus 2 squared. And in order to graph it, we need to draw 3 axes for the 3 variables. And so our final answer when we graph it should look like a potato chip or a saddle. And that is what our answer should look like. And once we classify it, based on the equation, we know it will be elliptical as a result of the 2 squares in the variables. And based on the shape, we know it to be a paraboloid. So our standard form of the equation 4y squared plus z squared minus x minus 16y minus 4z plus 20 is x equals 4 minus 2 squared plus z minus 2 squared. And then we have our graph, and we know it to be an elliptical paraboloid.